Hello friends, in this video we will discuss about an important topic called circular convolution, and this topic comes in the concept of discrete Fourier transform. Okay, so we in this video we'll discuss about this. Okay, so let's assume that we have two signals x1 of n, which is defined as x1 of 0, x1 of 1, and so on up to x1 of n minus 1. So the support of this signal is from 0 to n minus 1. Okay, so and we have another signal x2 of n, which is defined as x2 of 0, x2 of 1, and so on up to x2 of n minus 1. Okay, so support of these two signals is from 0 to n minus 1. So circular convolution of these two signals is defined as y of n is equal to x1 of n circularly convolved with x2 of n. Okay, so this is a way how circular convolution is written in shorthand notation, and this is given by summation k equal to 0 to n minus 1 x1 of k, x2 of n minus k modulo n. Okay, and here also n varies from 0 to n minus 1. So this n equal to 0 to n minus 1. So here note that we have to use what is called modulo operation. Okay, right. So if you expand this summation, so this will look like this. So this is equal to x1 of 0, x2 of n modulo n, because k equal to 0 in the first term, plus x1 of 1, x2 of n minus 1 modulo n, and so on. The last term would be x1 of n minus 1 multiplied with x2 of n minus n plus 1 modulo n. Okay, so and again n varies from 0 to n minus 1. So this would be our y of n. Okay, so what will note that n varies from 0 to n minus 1. So what will be the first term? So first term would be y of 0, which is given by x1 of 0, x2 of, because n is 0, 0 modulo n would be again 0, plus x1 of 1 times x2 of n is 0, 0 minus 1 is minus 1, minus 1 modulo n would be n minus 1, plus x. Okay, so and the summation goes on like this. And what would be the last term? Last term would be x1 of capital N minus 1 multiplied with x2 of, no, n is 0. Okay, so if you substitute n with 0, minus n plus 1 modulo n would be x2 of 1. So that's easy to see. And if you are interested in understanding modulo operation and circular shifting operation, please visit the above link. Okay, so there I explained about the concepts of circular shifting and modulo operations. Okay, yes, now let us continue with this. So now what happens if n equal to 1? So what will happen when n equal to 1? So y of 1 would be equal to x1 of 0, x2 of, now n is 1, 1 modulo n would be 1, plus x1 of 1 multiplied with x2 of n is 1. So if you substitute n with 0, so you'll get 0 modulo n, which is again same as 0, and so on, plus what would be the last term? x1 of n minus 1 multiplied with x2 of, now because n is 1, okay, so you'll get minus of n minus 2 modulo n, which is equal to 2. Okay, and you can continue like this, and what will happen to the last term? Let us say y of n minus 1, which would be equal to again x1 of 0 multiplied with x2 of, now n is n minus 1, okay, plus x1 of 1 multiplied with x2 of n minus 2, and so on. And what will happen to the last term? Plus x1 of n minus 1 multiplied with x2 of, n is substituted with n minus 1, and hence we will get 0, and hence we will get x2 of 0. So that would be our y of n minus 1. Okay, now let us go to the details of this. The whole thing we can write in matrix notation. Okay, so let us write our y of n as a column vector, so which is given by this y of 0, y of 1, and so on up to y of n minus 1. Okay, so if you look at the previous page, so this whole thing is a linear operation because we are just scaling and addition. We can write this whole thing in a matrix notation. Okay, so how does that look? So we will write like this. Okay, so we will try to fill this matrix, and this whole thing will get multiplied with our original signal. Let us say x1 of 0, x2 of, x1 of 1, and so on. Last fellow would be x1 of n minus 1. Okay, so let me rewrite it. Okay, so x1 of 0, x1 of 1, and so on up to x1 of n minus 1. Okay, yes, so now if you look at the first step, so what is happening? So first step is our complete x1 of n is getting multiplied with x2 of 0 and x2 of n minus 1, and so on, and hence what will be the first term here? This fellow would be x2 of 0, but what will happen here? This fellow would be x2 of n minus 1, and so on, and what will be the last term? This would be x2 of 1. Okay, so look at this equation, first equation. You will get x1 of 0 multiplied with x2 of 0, x1 of n is getting multiplied with x2 of n minus 1, and so on, and hence the first row we can write like this. Okay, and similarly what will happen to the second row? This fellow can be written as x2 of 1 and x2 of 0, and so on up to x2 of 2. Okay, so let us see what is the last term in the previous page. So last term would be x2 of 2. Okay, yes, okay, you'll get x2 of 2, and this continues, and last term would be x2 of n minus 1, and here they will get x2 of n minus 2, and so on. So on the last term here would be x2 of 0. So the whole circular convolution operation we can write in a nice matrix form given in this fashion. But if you look at this little bit carefully, this matrix can be formed by using just our second signal x2 of n. How do we do that? Note that this matrix is of size n cross n. Okay, and look at the first column. So first column is nothing but our x2 of n. Okay, so our first column, okay, this whole thing is x2 of n, and similarly second column is just one circular shifted x2 of n circularly shifted by 1 unit. So we can call this as x2 of n minus 1 circularly shifted by 1 unit, and so on. So similarly, so this fellow would be our x2 of, now we give n minus 1 shifts, and hence this last column would be okay, so this last column would be x2 of n, but it is shifted by n minus 1 units. Okay, so finally you will get, so what happened, this whole matrix is nothing but circularly shifted version of the first column. Okay, circularly shifted by version of the first column. So second column is nothing but circularly shifted version of first column by 1 unit. Second column would be, sorry, third column would be circularly shifted version of first column by 2 units, and so on. And the last column would be circularly shifted version of the first column by n minus 1 unit. So that is what we have written here, and this kind of matrix we call it as circulant matrix. Okay, so this matrix we call it as circulant matrix. Okay, let us call that to be C. Okay, so in shorthand notation, this whole circular convolution we can write it as y is equal to the circulant matrix. We have got this by using x2, so let us use that notation, x2 of n multiplied with our original signal x1. Okay, so what is this? This, the output we call it as y, and this the first signal x1 of n, let us call this as x1, and this whole matrix is C, which is of size n minus 1. Okay, so this matrix would be of size n minus n cross n would be of size n cross n. Okay, yes, so the finally the circular convolution is written in a nice matrix form in this fashion. Okay, where y is the output or circularly convolved output, and x1 is one of the signal, and cx2 is a circulant matrix got or obtained from the second signal x2 of n. Okay, so we will conclude this video with a small example. Okay, yes, so let's assume that we are interested in finding circular convolution of these two signals. So let us say x1 of n is 1 2 3 4, and let us assume our x2 of n to be equal to, let us say, 1 minus 1 2 and minus 1. Okay, so circular convolution of these two signals is defined as y of n equal to x1 of n circularly convolved with x2 of n. Okay, so just now we have seen that we can write this in terms of multiplication of circular circulant matrix obtained from x2 multiplied with our first signal x1. Okay, so this would be equal to, how do we construct the circulant matrix? The first column of that matrix is our original signal x2 of n, so this would be 1 minus 1 2 minus 1. So what is the second column? Second column is just circularly shifted version of first column by 1 unit, so this should be minus 1 1 minus 1 and 2. And similarly, what will be the third column? That is one more circular shift of the second column by 1 unit, so that should be 2 minus 1 1 and minus 1. And what is the final column? So that would be equal to, again, circular shifted portion of the third column by 1 unit, so that should be -1, 2, -1 and 1. So that is a circulant matrix constructed using the signal x2 of n. Okay, and this whole thing should be multiplied with our x1 of n, which is nothing but 1, 2, 3 and 4. Okay, so this simplifies to, so if you just do the multiplication, you will get 1 minus 2 plus 6 minus 4 as the first element, and -1 plus 2 minus 3 plus 8 as a second element, 2 minus 2, 3 minus 4 as a third element, -1 plus here you will get plus. Okay, so -1 plus 4 minus 3 plus 4 as the fourth element. Okay, so this finally gets simplified to, this first element would be 1 and second element would be, this is 5 plus 2 is 7, 7 minus 1 is 6, and last element here 2 get cancelled out, so this fellow would be -1, and here this 4 and -1 and 3 will get cancelled out, this would be equal to 4. So this would be the final circular convolution of x1 of n and x2 of n. So that again we can write that y of n to be equal to 1, 6, -1 and 4. Okay, so yes, hopefully this example helps you in understanding the concept of circular convolution. Thank you.